No leaks or rumors in this video. This is all the official slide deck from Nvidia, and I can publish this when the embargo lifts, so you're seeing it when it's all officially available. We have the RTX 4060 Ti coming with 8 gigabytes on May 24th at $399. A lot of people will be happy to see that they have not raised the 60 Ti price point compared to the previous generation, where we also had the 3060 Ti for $399, whereas all of the other releases we've seen so far in the 40 series raised the price. However, if you do want to get 16 gigabytes on that card, you will have to wait until July rather than May, and you will have to pay an extra $100 for the extra 8 gigabytes of VRAM. And we will get an RTX 4060 non-Ti also coming in July. You might notice that there's no price listed here. However, I did double check. I am allowed to tell you this since it wasn't in that slide deck. I do have other information, and it did say the same embargo time as this video, so I can confirm the RTX 4060 will also be available in July, starting at $299. So the 4060 will not only actually just be priced the same as the 3060, it's actually priced lower than the 3060 at $299 instead of $329, which is definitely good to see. Although, you know, we will need to dig into all of the specs and performance in this video, which we definitely have all of the official numbers from. I did press on if they had any specific dates in July, but what they were willing to tell me was that the July dates here are not the same. So the 16 gigabyte 4060 Ti and the 4060 non-Ti will come in July, but not on the same day. That's the most information I could dig out of them about that. Now, we're going to get into the specific performance details of each card. The rest of the video will just be basically going through the entire slide presentation that Nvidia has released. Okay, so we have the RTX 4060 Ti up against the 3060 Ti and the 2060 Super. You can see the overall teraflops of the shaders we have increased. I believe 22 T-flops puts it similar to 3070 Ti type territory and is a jump up from both generations. We can see the RT cores give us a big jump in RT performance. And tensor cores, we've got a big jump with the 4th gen cores. Again, we have DLSS 3 support, so you can do frame generation as well as super resolution as opposed to the previous generations. You get the NV encoder with AV1, which matters to streamers and content creators, but not to all gamers, but certainly a nice to have feature for a lot of people. Again, it will come in both an 8 gigabyte and a 16 gigabyte version, and I did confirm with Nvidia. Other than that change, there is no change to the specs between the two versions. Their performance will be the same when you don't need the extra VRAM, if that makes sense. And so that does mean that it had to go into the clamshell design, where the 16 gigabyte version will have the modules on the back of the PCB and then running into the same connector both ways. Anyway, whatever. That's how it'll work. Now, Nvidia wanted to make a big deal out of the fact that they have this massively increased L2 cache. They have 32 megabytes of L2 cache versus 4 megabytes of L2 cache on the previous generation, where they're saying that, yes, that technically gives it 288 gigabytes a second for its memory subsystem. However, they're giving an effective bandwidth of basically double that. And they talk in the next slide about how they are achieving that. Let's quickly run through the rest of the specs here, talking about power. This is a 160 watt card. They're saying that its average gaming power is only 140 watts. And again, also low video playback power and idle power. So as we've seen with the other 40 series cards, they are extremely energy efficient, and NVIDIA's previous claims on these numbers have been pretty accurate. So I would expect this to be the case, and so basically it is faster, has newer technology and features than the 3060 Ti coming in at the same price point. So all of that is definitely good to see, more energy consumption. Now, how are they arriving at this effective bandwidth versus the actual bandwidth? So basically what they're trying to diagram is how does the increased L2 cache actually help you? I thought this was pretty good diagram to help people understand. So your cores need to get some information. Hopefully it's in the L1 cache, but that's not very big, so a lot of times you have to go further. So your next step is to look in the L2 cache. If it's here, you get it a lot quicker than if you have to go to VRAM. The memory bus matters when you're having to go to the VRAM and can't just get it straight from the cache. So if you look in the cache, you might get hits. Those are these H's where you find the information that you want, and you might get misses, which are these M's. If you miss, you're not getting the info you wanted from your cache. Now you have to go to VRAM, and so now you're having to transfer over that memory bus. So what they're saying is that with the new generation, the L2 cache is much larger. And that means that you will have fewer misses when you look for the data. And if you have fewer misses, that means there are fewer times that you have to look to VRAM to get the information, which means you do not need data traveling across the bus as frequently. So they actually are able to test, and I asked so they really tested this. Yes, so they did limit the 4060 Ti to have a 2 megabyte L2 cache, which is what it would have ended up with, if you looked at it, compared to how they did their previous generations, is what they're saying. Although the 3060 Ti did have a 4 megabyte L2 cache, but so this is with a 2 megabyte L2 cache. They're showing the amount of VRAM traffic, right? So the amount of traffic across that system, right? And they're showing the green dots are where you get with 32 megabytes of L2 cache. The gray dots are where you would be with L2 cache, so lower is better here. There's less traffic. And so if you then look at it as performance gain, they're showing that, because of the larger L2 cache versus the 2 megabyte L2 cache, that's where you're getting these numbers, where without RT, you get somewhere in the 15 to 20% more performance with the larger L2 cache than if you didn't have it. When you're using ray tracing, you actually get an even bigger performance boost because for a lot of complicated math reasons, RT benefits more from having things in its cache than not using RT does. And so does DLSS 3, where it's actually they're getting an almost 35% performance boost for having the 32 megabytes of L2 cache versus having the 2 megabytes of L2 cache. And you can see they did test a number of games and applications here on a 12900K test system, and this is averaged across 1080p, 1440p, and 4K. So that is how they are arriving at this claim. The 554 gigabyte per second effective bandwidth is because if you need to cross if you need to cross that, use that memory bus about half as much, then it's effectively giving you the performance of kind of like doubling the bus. That is the claim. And in the end, what really matters is, so how does it actually perform, right? So in the end, how does it actually perform? Well, the 4060 Ti, their official performance claim is that without using frame generation, it is 15%, or in other words, 1.15 times the performance of the RTX 3060 Ti, and coming in at the same price of $399. Now, again, they want to highlight that it does include frame generation, which would then boost it higher, obviously. Now, remember that generated frames are not exactly the same thing as non-generated frames. However, I have videos on this topic. I do like frame generation in many single-player games, so I do think it is a value-added feature. But not every game has it. Not every game would be a game you'd want to use it in, like competitive gaming, all of that. But it is a cool value-added feature, and they are claiming a 15% performance gain over the 3060 Ti, even without using frame generation. Then you have the energy efficiency, AV1 encoder, all of that. They're claiming that, well, maybe that's the 15%, if you look at it by itself, is not the most mind-blowing of performance uplifts. They are saying that, if you're coming from a 2060 Super, which also came at $399, you are getting a 60% uplift from there. So for those people who skip a generation and then buy in the same class, you are able to buy at the same price point as the 2060 Super and get a 60% performance uplift. So there's the overall claims on that. Now, how are they Well, actually, you know what I want to do next? So what does that mean? Like what GPUs is this similar performance to? If we just look at the raw performance of the 15% performance uplift. So I'm actually going to pop over here. Sorry if I blinded you with the brighter screen. This is the Tech PowerUp relative performance database. It is not perfect, but it gets you decent ballpark figures where you can just click, and I like that it has so many GPUs. So we can just click on a GPU, set it as the baseline, and look at how other GPUs fall relative to this. So if we set the RTX 3060 Ti as the 100% baseline, and if we go off of the 115% of the performance, right, a 15% performance uplift without using all of the new features, then that places us in the basically in the ballpark of the RTX 3070. Again, this chart isn't so accurate that I would say it's definitely 2% faster than a 3070. We're going to say that it is looking like it is in the ballpark of the performance of the RTX 3070, and you know, you've got the 6750 XT in here. 3070 Ti is probably going to be a little bit stronger. So this is the ballpark that we're in. Now, the fact that the RTX 3070 still costs more than $400, draws a lot more power, and doesn't have frame generation, you know, or AV1 encoding and all that, does mean that it looks like the 4060 Ti is going to be an improvement in price to performance, both over the over the 3060 Ti at the $399 price point, and it will give you 3070 performance for less money than a 3070, plus with all the new features. So I think overall this is good, but I have a feeling that a lot of people, myself included, like a generational raw performance uplift to be more than 15%. So, in other words, I think there's a glass half full way of looking at this and a glass half empty way of looking at this. The glass half full way of looking at this is you are getting more performance for the same price with better energy efficiency and features. The glass half empty way of looking at this is, but a lot of previous generations of GPUs have given us a lot more than a 15% performance uplift at the same price point. Anyway, I think that's the two ways of looking at this, and I think both of them are valid. That being said, the 4060 Ti is going to be offering the best performance per dollar, feature set, and energy efficiency in its price class. It will be better than a 3060 Ti in terms of performance and features at the same price. So that's how we can look at it. Now, how did they arrive at these performance numbers? Well, here's the RTX 2060 Super tested in a lot of games. A lot of these are very recent games, all of that. And these are tested at their maximum settings, except for, including ray tracing and using DLSS. So basically 1080p max settings, DLSS and ray tracing turned on in games that support it. They're not saying which DLSS settings they're using. I would assume pretty aggressively, but again, it doesn't say. Now, notice that they do not turn Plague Tale Requiem and Resident Evil... excuse me, I just burped and I don't edit this video. So, there you go. Anyway, Resident Evil Remake with ray tracing preset rather than the max preset. Why are they doing that? Those use more than 8 gigabytes of VRAM. So that's something to talk about here in a second. Basically everything maxed out that you can max out without you going over the 8 gigabyte VRAM buffer. That's what a 2060 Super can give you. Now they are adding in the lighter colored line here. This is the 3060 Ti in those same games and same settings. And then they're adding in the green line, which is the 4060 Ti, which is now giving you your performance jump. Now, notice this has DLSS enabled in all games that have it. Not all these games have it. And some games have frame generation. So do you guys see how this is segmented here, right? So this first bracket here is games with frame generation. And this bracket down here is games without frame generation. So you can see the performance lift either way. So if you want to look at more at the raw performance, this is the set of games down here that you would be looking at. Now, using the settings that they are using here, including frame generation when it's available, you are seeing that the green lines generally are around 100 FPS or more. But again, I'm curious how aggressive the DLSS super resolution is being used here. If it's performance mode at 1080p, you have questions about the image quality of that. At least I do. But again, we'll need some private testing on that. Now, interestingly enough, they're now showing the 4060 Ti 16 gigabyte. And basically, the difference here is, notice they got rid of the footnote. Okay, what was the footnote? The footnote was that they couldn't turn up Plague Tale Requiem and Resident Evil Remake up to their highest preset because those would spill over the 8 gigabytes of VRAM. So the 4060 Ti, with its 16 gigabyte VRAM buffer, allows you to turn everything up to its absolute maximum settings without worrying about spilling over the VRAM buffer, and it'll cost you $100 more to do that. So basically, the performance claims for the 4060 Ti are the same, other than the fact that they can turn everything up to max without having to worry about the spilling over VRAM buffer. All right, that's all the information they've given us on the 4060 Ti. I'm very curious what you guys think about this, both with the 8 gigabyte version and the 16 gigabyte version. I have a feeling that a lot of people would have an easier time swallowing it's only 15% more performance, again with all the added features and energy efficiency, if it was the 16 gigabyte version at the $399 price. With the 16 gigabyte version coming in at the $499 price, I think we do have a little bit of an issue where, okay, if our performance level is around 3070, but right now a 6800 XT costs $500 last time I checked. I posted that in my monthly buying guide. The 6800 XT is certainly faster and has the 16 gigabytes of VRAM. So I think that's going to be an interesting question, is if people would rather buy the 16 gigabyte 4060 Ti for all of the Nvidia features and power efficiency versus the 6800 XT, there. So in other words, how many people are going to spend the extra $100? Like, VRAM's a big deal right now. A lot of people want the more VRAM, but is it worth $100 to double it and then look at the competition you're up against there? Certainly going to be interesting things to look at in the actual full reviews. Anyway, they got some more slides here talking about GeForce Experience optimized settings. So I think what they were getting at here in the press conference with these slides was basically, and you don't really need to worry about whether you're going to run over VRAM or not if you can just click the optimize button in GeForce Experience, and they get at some performance. They pick the settings for you basically, and we'll make sure. And they do say that this takes VRAM into account, and you'll be good. Now, I did a video a long time ago testing out some of their optimized settings and seeing if I agreed with them, and I didn't always. I actually asked them in the press call, going through this slide deck, about a little bit about how they reach the optimized settings. I just thought this was an interesting side note. I asked, is it completely automated, or are there like hands-on people doing this? Like, how are they doing it? And they said they do run a massive number of automated tests at different graphic settings and whatnot, but then they do have people hands-on tweaking the final decision that it does make for these and all that. So anyway, that's in the slide deck. And they also want to emphasize that not everything you do on a GPU is just playing games. And this is one of the big selling points for NVIDIA in general. And in my buying guide videos, I'm like, why would you pay more for NVIDIA? A lot of times, it's if you're going to be doing some sort of professional use case with like AI and things like that. Anyway, so we got all that. They also talk about again making sure that NVIDIA does have the the boost, not just reflex plus boost to give you the lowest latency possible in competitive gamings. Again, AI-powered content creation. My channel focused on gaming performance, but once again, for creators and all that out there, there's reasons to go with the NVIDIA stuff. Now, let's get into the RTX 4060 non-TI. Where are we at with this one? So basically, compared to the 3060, and remember, they didn't put the price here, but I did confirm $299. Okay, $299 in July. So it does actually cost less than a 3060. So it does have that going for it. Now, I think the biggest downside here is, compared to the 3060, it is 8 gigabytes versus 12 gigabytes. That is annoying, right? It's not a good feeling to get less of something compared to the previous generation. Even if the overall, energy efficiency, we're looking at, 115 watt card versus 170 watt card, and average gaming performance actually being 110 watts. Here again, they're talking about the in this case 24 megabytes of L2 cache, which is less than the 32 we saw in the other one. So we're not quite getting that like doubling of performance, but it is an increasing of performance when they're making this 453 gigabyte per second effective bandwidth claim. So that's how they're reaching that. Anyway, those are the specs. What about the performance? So the performance of the 4060 is, according to Nvidia, 20% faster than the RTX 3060. Now, with frame generation, of course, you would get more, and then comparing to the 2060, which came out at $349, they're claiming a 60% performance uplift and a more than doubling of performance if you're including frame generation in that number. So I've got mixed feelings here. Again, 20% performance uplift. That's not mind-blowing, although it's doing it actually for less money, not even the same money or more money. That's encouraging. But again, there is that caveat of you're losing 4 gigabytes of VRAM. So that's annoying. Here's the performance of the RTX 2060. And these are the same game settings resolutions as we just saw with the 4060 Ti. The same caveat of not enabling those settings in those two games that would spill over an 8 gigabyte VRAM capacity. Here's the RTX 3060 in those same games, and here's the interesting thing again, you could have probably on the 3060 turned those settings up in those games with the 12 gigabytes of VRAM, but they're not doing that here. And then here's where we get the 4060 in those same games, and again, they have the frame-generated games on top here, and the games without frame generation here on the bottom, and once again, certain games having to have settings tweaked to avoid the VRAM spillover. Now, I will say 8 gigabytes of VRAM at a lower price point, like $299, is less objectionable than it is at the $399 price point. So it does have that going for it. And they also did want to include this slide where they're saying, is the 8 gigabytes of VRAM causing problems to the 1% lows? So at least in these games, at these settings, they are showing that it does have better 1% lows than the 3060, even with its 12 gigabytes in these examples. So they are giving you the 1% lows here. So interesting stuff. They talked a bit about the future of gaming. Nvidia is certainly doubling down on the idea that AI acceleration and AI features is their vision of the future of gaming. And then here is the overall product line of the 40 series so far, where they are viewing the 4060 and 4060 Ti as 1080p high frame rate cards, and support and advertising the new features and all that, where they view the 4070 and 70 Ti as 1440p high frame rate cards, and their 4090 and 4080 as they just say, max frame rates, resolutions, and settings, all of that. So I am very curious what you guys think about all this. Again, here's the 40 series family. I do like the 60 Ti and 60 coming in at the same and actually lower. Remember the 4060 $299 price point as the 3000 series, whereas previously we had seen massive price bumps for the 80 class, 70 Ti class, and 70 class. Here there is a price bump if you go with the 16 gigabyte version. Here we get a price cut, but you lose some VRAM, you gain some performance. So let's look at the 4060 real quick in terms of what it's up against, right? So if we're talking this, 20% performance uplift from a 3060, where does that put it? So the 3060, if we click on that and set that as the baseline, so 3060 12 gigabyte as the baseline performance. Again, this chart not being 100% perfect, but if we go up 20% from here, so that's going to be putting it very, very similar in performance to a 2080 Super, at least at the 1080p resolution this was tested at. It'll, again, also pretty close to a 2080, probably a bit faster than a 6650 XT. It looks like it might come in a little bit slower than a 3060 Ti, so the 4060 might be a bit slower than a 3060 Ti, but honestly, it seems like it might be fairly similar. So maybe one way to think about the 4060 at $299 is it's a 3060 Ti, maybe slightly slower for $100 less than the 3060 Ti cost, with frame generation and AV1 encoding and better energy efficiency. So there's a few ways of looking at it. Once again, My thoughts on the 4060 are, there is a glass half full and a glass half empty way of looking at it, where you are getting more performance for actually less money. You're also getting less VRAM, but you're getting new features, all of that. Again, I think a lot of people would be more excited if it was just like, it's 50% faster, has the same or more VRAM, right? Then this would just be a everybody's excited, it's going to sell out kind of a situation. I think what my overall thoughts here is that Nvidia is giving us an improvement to performance per dollar. They are giving us more features, more energy efficiency. It just feels like they're giving us the minimum amount possible to probably still sell these, right? You know what I mean? And I think they're relying on the raw performance. I guess I should put it this way. They're relying on the raw performance uplift being about as low as possible to still, get people maybe somewhat excited at buying these. Make sure you are getting a better performance per dollar overall, even if you're just looking at raw performance. And then I think they're relying on the increases of the feature set and energy efficiency with AV1 encoding and frame generation to be more of the selling point. Whereas as previous generations of GPUs, I think they've relied on the just increase to raw performance as being more of the overall selling point. It'll also be very interesting to see where AMD falls with all of this. I think both of these card series, it's going to be, including AMD's latest generation, it's going to be interesting to see how they compete with the very inexpensive 6000 series AMD cards right now. Because again, a card like the 6650 XT is already an 8GB card that's looking like it's going to be somewhat comparable in performance. It's not on the list here, but the 6700 non-XT is probably going to be a fairly close performance competitor, but has 10 gigabytes of VRAM. But again, you don't get the frame generation. The RT performance will be very different. DLSS versus all of that. So anyway, I need to start, thinking about reviews, what sort of head-to-head comparisons you guys want to see. So maybe I'll leave you guys with that. What would be your number one head-to-head comparison you'd like to see first for all of these GPUs? Although the first one we'll be seeing, of course, is the 4060 Ti coming in on the 24th. So what do you want to see the 4060 Ti benchmarked against first? Let me know in the comments section, and let me know what you think about all this. I hope all of you have an excellent day.